This is part of the exhaust system on a 2011 Yamaha Apex snowmobile, and it's made out of titanium. Today's video is going to be on welding titanium, and since I've never welded on titanium before, I've watched plenty of YouTube videos, talked to some people in the trade that I worked with who have welded on titanium, and it seems as though the biggest thing with titanium is cleanliness. It's very touchy when it comes to contamination. According to stuff I've read, just the oils from your fingers, if you touch it without a glove on where you're going to weld, and you don't clean it with acetone before you weld on it, the contamination will embed in the titanium and you won't be able to get it out. So cleanliness is the big thing. So on this repair on the exhaust, you can see here that it's cracked right there. I'll zoom in on this. There you can see the crack. It's cracked down here, comes up into the weld, and then cracked about 3/4 of the way around. So I have to do a repair on this. So the first thing is to get it clean. Clean. And it's obviously got carbon buildup inside of the end of the pipe and all the way through the exhaust, so I have to be able to get that carbon out. So I started out with a rag, which I put on the end, taped on the end of a screwdriver. You can see how much carbon I've gotten out of it already, and that I covered that rag with acetone. So I taped the rag on in this form, and that rag, this rag again, is a clean one, as you can see, and I'm going to do the same thing again, where I'm going to go in and go up against where the spot is that I'm going to weld, and then just circulate that around in there, spin it around, and get that all clean, and we'll see how clean the rag comes out this time. Obviously up on this end it's not, because I haven't been cleaning that. The inside looks a little bit, but it's not too bad. I would say that this inside is going to be pretty clean where I need to weld by the time I get done with this swabbing. The arrow is pointing to where the crack started. The reason it started cracking was because of the abrupt edge of the weld on the pipe side. This type of a weld is susceptible to failure in any application. So the machine I'm using today is a Miller Dynasty 200 DX. I'm in DC. I'm on TIG high frequency impulse. I'm on pulsed arc. My peak amps is 85 amps. I'm at 1 pulse per second. My peak time, I will be at the 85 amps 35% of the time, and that means that 65% of the time I will be at my background, which is 50% of 85. That'll be my background amps. And my post flow is 15 seconds because titanium starts to absorb oxygen out of the atmosphere, which creates contamination and will cause cracking. And it starts doing that at anything above 700 degrees. So I'm only going to be able to weld 3/4 of an inch at a time with this jumbo 18 champagne cup I have. I got to keep the gas coverage with that cup over the top of that 3/4 of an inch. And I will be running gas inside as a purge inside of the exhaust at the same time. I have what's called a jumbo champagne cup. It's an 18 cup that I purchased, and it's really big. 332 tungsten, and I've got 1/16 filler wire, titanium filler wire. Now I did not touch on it, but I am also using a foot control, so those pulsed arc settings that I have are only going to be whatever I operated at with the foot control. So right now it's in the 15-second post flow. And I did a no-no, I pulled this out from under the cup while I was, and let it get contaminated out in the air. So what I'm going to have to do now is I'm going to have to nip the end of this rod off because the end of that rod is contaminated. Always when you're doing this, you always want to buy or have a piece of plate that is exactly what you're going to be welding on, so that number one, when you set your machine up, you know that you got all the settings correct before you go welding on somebody's very expensive product. Number two, in my case, I've never welded on titanium before, so I want to also test the machine out and just verify that I have a clue as to what I'm doing. It does weld, as other people have told me, a lot like stainless. And so it's the cleanliness is the biggest thing. Also the color, making sure that you don't get too much color around it by overheating it. It has to be purged internally like stainless. It has to be perfectly clean. You clean it first with acetone, then you wire brush it, then clean it again with the acetone just to make sure that it's clean before you start the welding. Something else I want to touch on is that when you're welding something like this that needs to be so clean and so contamination free, everything that you use on titanium should only be used on titanium. It shouldn't be used on anything else because of the contamination factor. It's way touchier than aluminum is, and aluminum is bad enough. So I bought a little toolbox. It's a titanium only kit, has rubber gloves in it, acetone in it, a side cutter is used only on titanium. Good little wire scratch brush, stainless, only for the titanium. A file and an assortment of wire stainless steel brushes for my little die grinder. Okay, so I'm wiping it all down on the exterior with acetone before I go over it with a wire brush. For my purge setup, I have one regulator out on the bottle, straight argon, 100% argon. This is the incoming hose for the straight argon. Then I have a T in line before it goes into my Dynasty 200 DX. That T hose goes out, runs across, and ties into a little valve so I can turn it on and off. So on the purge on this end, I have a valve on the purge line going in, which now is open. It is purging right at the present moment. The purge hose is going in on the bottom of this painter's tape, and then this piece of tape is just holding the purge hose so that it doesn't fall out while I'm welding, because that would contaminate the weld, as that would mean that atmosphere and oxygen would get inside. Now, argon being heavier than air is always going to go to the bottom of the area. So if I'm welding on the top side here and there's no argon up there, it's not purged out, then it's going to get sugar on the inside and it's going to get contaminated. So I have a very small hole pierced in the top of this painter's tape so that any atmosphere and oxygen will bleed out through that hole. I also have the back end of this completely taped off solid. Now I don't care about back here. That's not going to make any difference. I'm welding here. That's what I'm concerned with. So that's why I'm purging in here and bleeding out the top, plus it should bleed out through the crack that's there. I use a C-clamp to clamp the part down to the table and a woodworker's clamp to be able to pull it back up into place where it needs to be. And I use a vice grip on the back side for my ground. That way I know I don't lose any ground while I'm doing this. I'm going to put about a 1/2 inch tack up on the top side. After this has purged for about 15 minutes, then I'll go on it and I'll put a 1/2 inch tack up there. Then all this clamp and stuff can come off and I can continue, and I'll probably go 1/2 to 3/4 of an inch, and I'll just circulate around until I get the full thing welded. I just want to show you from the bottom side here, because it's already clamped in the vise. So one more thing I wanted to explain. So the crack visually ends right here. I cleaned it up about 3/4 of an inch back past that crack, because where you visually can see that the crack ends usually isn't where the crack ends. So you got to run that up into that crack until that crack disappears. So that's why I'm 3/4 of an inch past that crack, so that when I'm welding up along in this position here, that I can make sure that I get to the end of the crack. Otherwise it will just continue to crack where I left off if I didn't get all of the crack. Okay, my purge has been running for about 15 minutes now, so I know for a fact I should have plenty of argon up in this area and no oxygen atmosphere. Cut the tip of my rod off. I'm ready to go. I've got everything on. I got my side cutters here for nipping my rod. Something else to take into consideration is the original weld on here was wire fed, so I know that this is about a 0.62 wall, that's in inches, so about a 1/16 of an inch thick, but where this weld is much thicker, so that's going to take a lot more heat to get it molten against here, but against the weld, but on the 1/16 thickness it's going to take a lot less. So I will be able to concentrate more heat up on the weld and less down on the 1/16 wall titanium. So I'm going to start my weld up on the actual weld so I get heat up there. And there is a tack, about a 1/2 inch long as I explained. Bring you in so that you can see that a little closer. So there is my first tack, or actually bead of weld, to be able to weld this up. So that's the first section. You can see that the crack pulled tighter, and it's up inside of there, and it looks good. I have coloring on the outside, which you're going to get some coloring on the outside, but you want it around the weld itself. You want it to be kind of a silverish. You don't want to get too much color too close to the weld, because that means you're getting contamination. Couple suggestions that I would make after doing this is, one, just like with aluminum, if you contaminate the tungsten, you got to go clean it. And another one is that I would definitely not go without this clear cups, because you want that tungsten to be in as far as possible. And with the clear cups, you can actually watch what's happening with the tungsten and the arc through the cup itself. You need to keep the cup in a vertical position. You don't want to lean it in any direction at all, or you're going to lose your gas coverage and you're going to end up with some contamination. So you definitely need to keep your cup in a vertical position. So make shorter passes, like the 1/2 inch ones I'm doing. That way you can keep your cup in that vertical position so that you know you have good gas coverage. Here are some other things I learned during this project. Clean the filler rod with a scuff pad and then acetone prior to starting. Snip off the end of your filler wire after each weld just in case it got contaminated. Your welds should be a 1/2 inch maximum length unless you have a helper who has another purge hose to keep coverage so that none of the hot weld gets exposed to the atmosphere. Start gas flow prior to your arc so you are positive you have gas flow to your work before the arc starts. And wipe the weld with acetone after every wire brushing to make sure the metal is clean prior to the start of the next weld addition. So looking at it from the inside, you can see it's not full penetration in some spots, but as you look at it, the top and certain sections of it do have full penetration. The crack over on the side over there, because that was all thin material, has full penetration. And it looks nice and smooth inside. Where I have full penetration, it looks very nice. So my shielding gas was very good. All the way up around the top side. I don't know if you can see that through the camera. But there in the mirror, I can see the full penetration around on the top, and that all looks very good. So there it is. The repair is complete. It's not as pretty as some could make, but it'll do. There's the crack. So I started on the crack from the opposite side, and I started about a ½ inch before where the crack started. So I started about a ½ inch this side of the crack and worked into it. Thanks for watching.